So AP Chemistry topic 7.13, 7.13, I don't know why I said it like that. pH and solubility. So today's objective is be able to identify the qualitative effect of changes in pH on the solubility of a salt. So we're also looking at equilibrium concepts and applying them to weak acids and bases. So we see formic acid HCHO2. So the fact that it's weak, you can see that it has some kind of equilibrium expression. So you have your formic acid plus water acting as a base, forming a conjugate base and a conjugate acid. So K sub A equals a concentration of CHO2 plus times H3O plus over HCHO2, and that equals 1.8 times 10 to the negative 4. Adding an acid would make the equilibrium shift to the left because the hydrogen ions would react with water, and it's going to form H3O, the hydronium ion H3O plus. So by adding more H3O plus, it's actually going to kind of shift it back towards the reactants. Adding a base, something that ends in OH, would make the equilibrium shift to the right. The OH will react with the hydronium ion, the H3O plus, to form water. Taking out hydronium would drive the equilibrium towards the products. So similarly, you have a weak base such as ammonia, and then you add acid. Water is going to act as an acid. It's going to form a conjugate acid and a conjugate base. Adding acid, HA, would cause the H plus to react with the OH to form water, and it will drive the reaction to the right to reestablish equilibrium. Adding a base would drive the reaction to the left because you have a lot of OH now, so you're going to try to go towards the reactants. So this equilibrium we're looking at, you have two colored species. CrO42 minus is yellow, while Cr2O72 minus is orange. So predict the color in the reaction vessel by after adding something to it. So you have 2 CrO42 minus plus 2 H plus, producing Cr2O72 minus plus water. Adding NaOH. So by adding NaOH, what you're actually going to do is you're actually going to have this OH group interact with the water there, so water with the H plus ions, to form water. And in forming water, it's going to pull away from the reactant. So at equilibrium, the reaction will shift towards the reactant side. That means you're going to have more reactants than products, so it's going to have a yellowish color because you are taking away from the products and forming reactants. By adding HCl, by adding hydrochloric acid, what you're doing is you're actually adding more H plus. And by adding more H plus from the ionization of hydrogen and chloride ions, you're adding more H's, therefore the H's are going to, so by adding more reactant, you're going to drive the reaction towards the products, so it's going to have an orange color. Okay, so the last one, addition of barium nitrate. You have two KSPs for barium chromate and dichromate. So using the KSP, we should remember from before which salt will precipitate from the barium nitrate. Since the barium chromate has a lower KSP, it will precipitate out, pulling chromate, the CrO42 minus, from equilibrium. By removing that reactant, we're going to shift the equilibrium towards the reaction side to compensate for that loss. So therefore, kind of like the other ones, you have a yellowish color. Given the following reactions, what will happen to the concentration of calcium when the pH of the solution decreases? So give yourself a minute, you can stop the video, work on this. So some things we need to think about. So when the pH decreases, it is more acidic. So the hydrogen ion concentration increases. So the following reactions going on. So by increasing the hydrogen ion concentration, we'll shift the we'll look at the second one, for example. It will shift over towards the reactant site, H2CO3. If you notice that when the third does this, the third reaction shifts over here, it will decrease the carbonate concentration. So by decreasing carbonate, by removing carbonate, because we're going towards here, so we're taking away from this. So by removing this carbonate concentration, the reaction will shift to the products in the first reaction. So what is happening to the calcium ion concentration? The calcium ion concentration will increase. Since the hydrogen ions are using up carbonate ions to make its products. So in the end, calcium ion, the concentration will increase. So that's it for now. Let me know if you have any questions. Thanks.